In this video, we're going to look at some of the prerequisite skills you need if you're going to take trigonometry, say, during the summer at the high school level, or it could be at the college level. We're going to focus on the very basic ideas. We're going to look at the sine of an angle, the cosine of an angle, and the tangent of an angle. Now, there's several ways you can define these functions. We're going to look at the first and basic method using a right triangle. So here's a right triangle. I have the angle theta. It's important to know that what we're going to look at today in this video, it has to be a right triangle. So you're going to have one 90-degree angle here at this point. The side opposite the 90-degree angle, I here labeled it C, is the hypotenuse of the triangle. And then the other two sides, I've labeled them A and B. Those are called the legs of the triangle. Also important to know that this angle, the other two angles, this one of course is 90 degrees. The other two angles are complementary. So they have to add up to 90 degrees because the total degree in a triangle, add up all the angles, they add up to 180. So if this is 30, say, they tell you this is 30 degrees, then right away you know that the other side or the other angle has to be 60 degrees because they have to total 90. Altogether, the three have to add up to 180 degrees. So here's a definition for the sine of the angle. And again, when we talk about the sine, the cosine, and tangent and so forth, we're always referencing one of the acute angles, either this angle up here or the angle that I have labeled as theta. So here I'm referencing angle theta. So the sine, though I have it here, is equal to, by definition, side B over side A. Sometimes you'll say the opposite angle, or the opposite side from the acute angle is B. The adjacent side is, in this case, A. So for the sine, it's opposite over the hypotenuse. So B over C. For the cosine, it's the adjacent side right next to it. That's A over C. C is the hypotenuse of the triangle. And C, or the hypotenuse, is always the longest side because it's opposite the largest angle, 90 degrees. Tangent, they say, is opposite over adjacent. In this case, B over A. Now there's three other functions you can also use in trigonometry. Corresponding to sine, the reciprocal is cosecant. Corresponding to cosine, the reciprocal is secant. And for tangent, it's cotangent. But we're going to use these for right now. You can do most of the problems using one of these functions. The main thing to know is how do you find the sine or the cosine of an angle. So if I give you what is the tangent, they tell you what is the tangent of 25 degrees. You can use any calculator. Doesn't have to be a graphing calculator, but any calculator. And if they give it to you in degrees, the one thing you have to make sure of, here's the 83, go to mode, and make sure it's set to degree. Notice the angles can be in radian or can be in degree mode. Set it to whatever it is. Just highlight radians if it's in radians and hit enter. In this case, I already have it in degrees. So if you want the tangent of 25 degrees, just hit the tangent right here. And then 25. Don't have to put the degree because the calculator already knows that it's in degrees. Just close the parentheses, hit enter, and it tells you the tangent of 25 degrees is 0.4666 and so on. And you can round off accordingly. Now if you got it's over here, again, go to mode, and notice this one is in degrees. The difference though between the 89 and in this case the 83, is that the 89 gives you exact answer. Notice I have it set to auto here. So it's gonna try to give me the exact answer. So in this case, if I enter, say, tangent, so find the tangent and say enter 25 degrees, it's going to want to give me the exact answer. So I hit enter. Notice it tells me tangent at 25 degrees. So obviously if you're working a problem out in a test or homework, teacher asks you to find the tangent at 25 degrees. He or she's got an approximation. If there is an exact answer, yeah, you give the exact answer. So what you have to do with the 89, especially if you have it set to auto, is do this. Go second and then tangent and then 25 and hit this little diamond right here next to the alpha. Hit that and hit the enter. Notice the equals mark that it has there. It's approximation. It tells you 0.466 3008. Notice, same answer I have over here. The 83 was set to more decimal places, but that's the way it works. So keep that in mind if you have an 89 calculator. And that works the same way if you find the cosine of an angle or the sine of an angle. One thing you should know also, talking about prerequisite skills. Obviously, when you go into trigonometry, whether it's high school trigonometry or college level, you got to know your algebra. So at the very least, you need to be able to solve linear equations, quadratic equations by factoring, quadratic equations using the quadratic formula, multiplying monomials or polynomials, a trinomial times a binomial. All the basic algebra, you need to know that. Now, one thing associated with a right triangle, and again, what we're doing here, these definitions of the sine, cosine, and tangent only apply to these acute angles here, either this angle or this angle, because we have a right angle. If I have a triangle like this, it's not a right angle. It doesn't have a right angle. I can't say this angle here is theta. I can't say theta, then if I'm looking at tangent, it's opposite over adjacent, because this is not a right angle. Only works for a right angle. And this tells me that Pythagorean theorem, that if I have a right triangle, the square of C, or the hypotenuse, is equal to the sum of the squares of the other two sides. So anytime you're given a right triangle and you know two sides, you can easily find the third side by using this formula here. So let's go through some examples. So in this case, find the value of x/y. Some will have an x, some will have a y, some will have both. So here we have, okay, so here's my right angle right here. I'm given two sides of the triangle. I want to find the third, or x. Notice x has the position of the hypotenuse. So I know that if I take the square of the hypotenuse, is equal to the sum of the squares of the other two sides. So 4 squared is 16. 3 squared is 9. 9 and 16 is 25. I want to find x. So x squared is equal to 25. So what number squared gives me 25? 5. So the missing side is x equal to 5. Now anytime you square the one side of a triangle and it equals to the sum of the squares of the other two sides, it has to be a right triangle. That's one way you can test to see if you do have a right triangle. Of course, you're given that it's a right triangle. This is a symbol for 90 degrees. Let's look at the next one. This one I'm given a right triangle again, and I have an x and I have a y. And I'm given one angle of the triangle and one side. Let's try to find, doesn't really matter here in this particular case, let's try to find x. So to find x, I have to use two quantities. So I have an angle, I have this side. So how can I use this angle and this side and the missing part? Well, here's the deal. Tangent of 53 degrees is y over 3. Tangent of 53 is y over 3. I can use that equation to find y. But let's say I wanted to find x first. Well, which function is going to use the x? Well, let's see. Sine of 53 is opposite over hypotenuse. That's y and x. That's not going to do it because they're both unknown at this point. So let's do this. How about cosine of 53 degrees? What is cosine equal to? It's equal to the adjacent side, which is in this case is 3, over the hypotenuse, which is x. Okay, now I solve that equation for x. So again, you can do this and cross multiply if you want. The same thing as multiplying both sides by x, because notice, if I cross multiply here, if I put the 1 under the cosine 53, it gives me x times cosine 53 and then 1 times 3. But if I just multiply both sides by x, it gives me the same thing, because if I can multiply this side by x, it cancels here, and it puts it over here. So I get x times the cosine of 53 degrees. And again, I don't have to put the degree when I use the calculator, because I already have the calculator set to degrees. So I get x times cosine of 53 degrees is equal to 3. Now I want to find x, so I want to get rid of this cosine of 53. So let's just divide both sides by the cosine of 53. Divide over here by the cosine 53. So this cancels here. And x then is going to equal to 3 divided by cosine of 53. So I take the calculator. I'm going to use the 89 here. So I want the answer is going to be 3 divided by the cosine of 53. So let's do it this way. 3, then divide, and it's going to be cosine. So second cosine of 53. Now I expect that the calculator is going to give me the same thing back. So I'm going to use the diamond here to get, because I want a decimal approximation. So hit the diamond and then enter. And I get x is equal to 4.98. And that I run it out to 2 places. They ask you to run that out to 1 place. You put 4 point, add 1 to the 9, that'll be 5.0. But I'll leave it to 2 places. This will be 4.98. So that's x. Now what about y? Y is also unknown, and they want us to find y. In some cases they might just ask you to find one side. So here I want y. So let's see. I know the tangent of the angle, in this case 53, is opposite over adjacent. So that will do it, because if I say tangent of 53 is equal to y over 3. Again, I can put this over 1 and then cross multiply. But I just like to multiply through by 3 to get rid of the fraction. So multiply by 3, it cancels it here. Then I'm going to multiply both sides. So over here, it puts tangent, but 3 times the tangent of 53 is equal to y. So then I just take my calculator then, and y is going to equal to 3 times the tangent. So I just put second tangent of 53 degrees. Close parentheses here. The 89 is kind of picky. The 83 or the 84, it might give you the answer without the parentheses. With the 89, you got to be careful here. So put parentheses there. Again, I expect the calculator is going to give me the same thing back, because there's not going to be an exact answer for this. So whenever you expect that, hit the diamond key here and then hit enter. That gives me the approximation. But see, I didn't hit it hard enough because it still gave it to me. See, it gives me the same thing back, except in a different form. So let's do this. There it is. 3.98. You gotta hit this diamond key. I didn't hit it hard enough. 3.98. So y then to 2 places is 3.98. So x came out to 4.98 and the y came out to 3.98. Now I want to point out to you that sometimes they're going to tell you to solve the triangle. In the first stages of these types of problems, they only ask you for one side or one angle. Here we had 2 sides. Now they could have said solve the triangle. They would have given you this 53 is given, 53 degrees for this angle here, and then x and y is missing, and you have one of the legs of the triangle is 3, and now we're missing the other angle. So if they ask you to solve a triangle, they're going to want you to provide the measure of every angle. Obviously, one is always going to be 90 degrees, if it's a right triangle. They will be in these types of problems. Now I'll use the 83 on this one here. If we know this angle is 53 degrees, what's this angle over here? Well, 90 minus 53, or 37. So now you know every part of the triangle. You know all 3 angles. Got 53, 37, 90, and then you know all 3 sides. Remember, they only ask you to find one side of a triangle. If you're given 2 sides, you can use the Pythagorean theorem. You don't need any angles. You can just use the Pythagorean theorem like I did in the first one. Now let's look at this one here. Here's a right triangle. They give you 2 sides, 4 and 12. Now notice, when I point out this to you, let's suppose they want you to find this. Let's suppose they put an x there. Got the other sides are 12 and 4. Well, you could use the Pythagorean theorem. This is what I'm talking about. You know the square of the hypotenuse is equal to sum of the squares of the other 2 sides. So this is going to be 4 squared plus 12 squared. So x squared is equal to 4 squared is 16. 12 squared is 144. So we add those up. We get 160. So taking the square root of both sides, the square root of x squared is x. The square root of 160. x then is equal to 160. Doesn't have an exact square root, so the only thing you can do here is simplify it. So let's break this up, divide by 2 here. 2 into 160 will go 80, and then 80 is 16 times 5, and 16 does have a perfect, it's a perfect square, so we can take the square root of that. That'll be 4 outside, comes outside. And then 2 times 5 is 10. That's not a perfect square, so that stays under the radical. So if they wanted x, using the Pythagorean theorem, we get x is equal to 4 times the square root of 10. But in this case, they want y. This is an angle. So which function would you use? Would you use sine, cosine, or tangent? Well, let's see. Sine would be, use the sine. It would be the sine of y is equal to the opposite, that would be 12, over the hypotenuse, but we don't have that given, so we can't use this. If we use cosine of y, that would be the adjacent over the hypotenuse, but we don't know that either. So that leaves us only one choice then. Tangent of y, we're looking for an angle, that's why I have the degrees on that one, of 12 over 4. Tangent is opposite over the adjacent, so that's 12 over 4. I could leave it like that, or I could say 12 divided by 4 is 3. So now we want y. What is y? This is where you use what is called the inverse function of tangent here. I'm going to use the 83 first, and here's what you do. Anytime that you're looking for the angle, this is where you're going to use the inverse. Here's tangent right here, and notice right there is tangent with a negative. So I hit the second, and you access the inverse of tangent. This is so good. Notice tangent with a negative 1, that's tangent inverse. Enter 3, well, you can enter it the way 12 over 4. And I'll do it that way just because some won't divide out, so I'm just put 12 divided by 4. I could put 3 and it works, but you might get one that's 7 divided by 3 or 7 over 3 where it doesn't go even. So I'm going to leave it like that. Hit enter, and there you have it. 71 degrees point, or 71 point whatever. So let's just leave it as 71. Round it up to 2 places, that's 57 degrees. Or you round it up to 1 place, 71.6. We'll leave it here. So when you're looking for an angle, you're going to use that. It could be the tangent inverse, or it could be the cosine inverse, or it could be sine inverse, depending on what they ask. So let's go to the next one. So this one again, I'm given one angle, one side, and I need to find the other two, the lengths of the other two sides. I can't use the Pythagorean theorem because I only know one of these. If I had two, if say the y was given and 6.5 was given, then I could use the Pythagorean theorem. So here what I'll do is, let's say I want to find y first. What I use, that's what you have to figure out. Would you use sine, cosine, or tangent? So again, tangent of 41 is this over this, x over 6.5. Cosine of 41 is 6.5 over y. So that's going to work. So let's try the tangent. Tangent of 41 degrees. Whatever function you use, whether it's a sine, cosine, or tangent, just make sure that it utilizes the missing part for sure. So that's opposite. That's x. Tangent is opposite over adjacent. That's 6.5. Now if I didn't know this 6.5, then I couldn't use the tangent there. But now, once I have it in this form, then again, you just cross multiply, put this over 1 if you want. I just like to multiply by whatever's in the denominator, clear a fraction. So this and this would cancel, and then it puts the 6.5 on the other side, and then it's tangent at 41 degrees, and that's going to give me x. So this time I'm going to use the 89. Remember, they have to be set to degrees if you're working with degrees. So I'll just enter then 6.5. Okay, right here, 6.5, tangent of 41, and then hit the tangent. Find your tangent. Second, tangent of 41, close parentheses, hit enter. So x is equal, I'll run it out to 2 places again, 5.65. You want that out to 1, you write it out as 5.7. So that's your x. Now at this point, now you know two of the sides. So if you wanted to use the Pythagorean theorem, you could. You could say y squared is equal to 6.5 squared plus 5.65 squared. Compute and then take the square root to find y. You have more error though when you've rounded off something. So I like to just use for the most part, try to use the data that's given. So I know that the sine, now I need y. I could use the Pythagorean theorem like I said, but I'm going to do it this way. Cosine. Because cosine is adjacent, which is 6.5. Now I want to solve for y. I don't like the variable in the denominator, so again we're going to cross multiply, or the same thing as multiplying by y here. You can put this over 1 if you want, but it's y this way, so this will be y cosine 41 degrees is equal to 6.5, because this y and this y canceled. Now to isolate the y, then I want to get rid of that cosine, so I divide both sides by cosine. So dividing the left side by 6.5, dividing the left side by cosine of 41 degrees cancels this and puts it on the other side, cosine 41 degrees. Then we just do the calculations. So what do we have? 6.5, y is equal to 6.5, so 6.5 divided by, gotta get the cosine, so second gives me cosine here with a z there is cosine, and then 41. And again, to make sure I get a decimal approximation, which is what I expect here, I hit the little diamond here. Okay, so this one here, next to the alpha to the left there, hit that and then enter, and I get 8.612, and so round off. So I'm going to round that out to two places again, so this will be 8.61. And notice, on this one we got two sides of the triangle. All we need is one more angle, and we would solve the triangle. Like I said, right now they're just asking you for two sides, find one side or one angle. Sometimes they'll ask you to solve the triangle. So we got pretty much everything here. We have one side is 6.5, another side is 5.65, another side is 8.61. All we need is this angle right here. But we know these two angles add up to 90 degrees. So all I have to do is subtract 41 from 90 degrees, and we get 49. So if they wanted this side, or this angle rather, it's 49 degrees. Now that's the last problem, but this will be a bonus. Let me make this a little bit bigger here, and it still doesn't look right here. So let's suppose this is not a right triangle here. Let's suppose that this side is given to be 4 and this side is given to be 4. Because when you get into more advanced trig, sometimes you have to generate your own figure. Let's suppose they wanted to find the base. We just label this as B for base. So I want the length from here to here. We don't have a right triangle, so we do this. From this vertex here, I drop a perpendicular like this. This creates a right angle right here. So this triangle right here, and of course this other one on the other side is also a right triangle. They're similar triangles, which is something you also have to know when you get into trig. Similar triangles, corresponding sides are proportional. So now I'm going to call this x. I want to find x. Because I dropped this perpendicular, it actually divides the other side into two equal parts. So basically the base is going to be whatever I get for x doubled. And the other thing we're given is this angle is 62 degrees. And this angle is 62 degrees. So what I want to do is first find x. I want the base, remember. I want the length of the base, which is going to be 2 times x. So I have an angle of 62 here, and I could use either triangle here. It doesn't really matter because they're similar triangles. But here, if I take 62, I want to use the x and the 4. So from this perspective, okay, it's going to be cosine. Remember, as to the cosine or the sine of the acute angle. So 62 from this perspective, the opposite side is over here. The hypotenuse is right here at 4. So the cosine of 62 degrees is equal to the adjacent, in this case is x, which is what I'm looking for. So I need to use it. over the hypotenuse. So then again, I cross multiply, or I just like to multiply by whatever's in the denominator, because that's going to put it over here. 4 cosine of 62 is equal to x. So the value of x will be given by, take my 89, and it'll be 4, I'm going to multiply times, so it'll be second cosine of 62. Again, I'm going to hit the diamond key to get an approximation. So hit the diamond key and then enter, and I get 1.87. Or I get that x, rounded out to 2 places, is 1.88. So the base will be twice that, which is equal to 3.76. And this was just a bonus, just to give you a taste of what you need to do sometimes, because they're not always going to give you the right triangle. They might give you a problem and you have to generate the triangle and come up with the information you need to solve it. Thanks for watching. We'll see you next time.